So aromatic compounds, non-aromatic, one of the important and compulsory question is coming from this particular area. So here put the heading aromatic compounds. Aromatic compounds, non-aromatic, anti-aromatic compounds. Aromatic and anti-aromatic compounds. So generally we had three types of compounds: aromatic compounds, anti-aromatic compounds. Actually aromatic compounds means sweet smelling compounds. In olden days they told that so the compounds which are sweet smelling compounds are aromatic compounds in olden days. But for example esters, RC double bond OR, ester is also sweet smelling compound. So that's the reason it's not an aromatic compound even though it is sweet. So that's the reason all sweet smelling compounds are not aromatic compounds. So for example, all the glitters are not gold, right? So all sweet smelling compounds are not aromatic compounds. So that's the reason we discussed, we gave some particular points to identify the aromatic compounds and anti-aromatic compounds. So here is non-aromatic compounds means if the compound is neither aromatic nor anti-aromatic, obviously it would be non-aromatic. Okay, so we'll discuss what exactly the aromatic and anti-aromatic cases. Right now. So aromatic, anti-aromatic. Is it audible, right? Hello? 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 Are వినిపిస్తుంది కదా? Hello? 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 వినిపిస్తుందా? Right, aromatic and anti-aromatic, one of the important topic now. The compound should be, first pointer, compound should be cyclic. Whenever whatever the compounds are cyclic, so these all points should be satisfied, then only, so 4 points are there. Compound should be cyclic, here also compound should be cyclic. Compounds are having the resonance. Right now whatever we are discussing means conjugation will be there, hence compound should have the resonance should be present. Resonance or we know conjugation also we could say. Resonance or conjugation. The compound should be planar. Compound should be planar. So how should we know the planar? Generally sp2 compounds are trigonal planar. Planar means what, Nana? All are in the same plane, right? The four corners are in the same plane, right? So for example, the hand is in the plane. For example, if it is like this, it's not in the planar. In this case, it is planar, right? Planar. And the compound should obey the Hückel's rule. Hückel's rule. Hückel's rule is what? 4n plus 2 pi electrons. It is 4n pi electrons. So this is important point which we need to do. Hückel's rule. Right, I'll discuss what exactly the Hückel's rule. I'll discuss exactly Hückel's rule. What is exactly Hückel's rule? Right. So 4n plus 2 pi electrons. 4n plus 2 pi electrons means what exactly? Here n is equals to, we can take 0, 1, 2, 3, 4, dash, 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 right? If n is equals to 0, Nana, if n is equals to 0, so how many pi electrons, tell me? 4 into 0 plus 2 pi electrons. Nothing but how many pi electrons? Is it audible, right? Hello. How many pi electrons? 2 pi electrons. If n is equals to 1, 4 into 1 plus 2, 6 pi electrons. If n is equals to 2, 4 into 2 plus 2, right? 10 pi electrons. If n is equals to 3, n into 3 plus 2, right? 4 into, not n into 4, right? 12 plus 2, 14 pi electrons. So like this, 2, 6, 10, 14, 18, 22, like that. So it's increasing. Any compound, if it is having this many pi electrons, means it obeys the Hückel's rule. For example, try to understand. In this case, one compound which I am giving you like this, each pi bond is having 2 pi electrons. Write it down. Each pi bond, 2 pi electrons. Each pi bond, 2 pi electrons. Sometimes if lone pair means negative charge, if it is participating in the resonance, that is also we need to consider 2 pi electrons. Okay. So for example, here is negative charge is there. Negative charge also we need to consider what, Nana? 2 pi electrons. Right? This is 2 pi electrons. This is also 2. 2 plus 2 total 4 pi electrons. In this case, only 2 pi electrons. Now, in these two cases, which is obeying the Hückel's rule, the 4n plus 2 pi 1. Right? This is 2 pi electrons, 2 pi electrons. Is it matching or we need to consider it? Right? So, for example, I am having 6 pi electrons with me. So, means I am obeying the Hückel's rule. For example, I am having the 4 pi electrons. I am not obeying the Hückel's rule. For example, I am having 5 electrons. Is it obeying the Hückel's rule? No. How? 2, 6, 10, these 3 values just keep in your mind. And that is 4 pi electrons. For anti-aromatic, 4 table we need to remember. 4n pi electrons. 4n pi electrons means what? For example, 4n pi electrons. So n is equals to 0 means total 0. So nothing. So n is equals to 1. 1 means what, Nana? 4 pi electrons. If n is equals to 2, 8 pi electrons. N is equals to 3, 12 pi electrons. N is equals to 4, 16 pi electrons. If any compound, so along with cyclic, resonance, planarity, and if it is having these many number of electrons, that is anti-aromatic. Okay? For example, try to understand. In this case, how many pi electrons are present? Hello? Online guys, sometimes just keep on responding. 4, because whether you people are right. 4, right? 4 means what? It obeys the anti-aromatic. It's anti-aromatic case, right? So cyclic, first we need to see the cyclic structure and right, continuous conjugation. Total continuous conjugation should be present, not off of the conjugation. So total cycle should have the continuous resonance. So planarity no need to check, because whenever the compound is planar, then only resonance is possible generally. Okay? Hello. And Hückel's rule. So 4n plus 2 pi is nothing but 2, 6, 10, 14, 18, that is aromatic case. And if it is having this, right? If it is having right, so cyclic, resonance, so we'll discuss one by one. Okay, hello. For example, this is a compound, the beginning compound which I'm giving you like this. This is cyclic, right? Cyclic. Yes. Is it having the resonance, Nana? Resonance is present, because here we didn't have any, right? It's already carbon, 4 bonds already there. Resonance is not possible. The resonance is not possible. Obviously, planarity is also not possible. But 2 pi electrons are there. 2 pi electrons. So means it is aromatic. It is aromatic. But the thing is, for aromatic, total 4 should be satisfied. 4 points should be satisfied. But now 2 are not satisfying. Means this is comes under non-aromatic. Non-aromatic, because it is sp3 hybridized carbon, tetrahedral shape sp3, and right, already carbon is having four bonds, right? No. So either carbon should have the s, right? It should have the resonance, right? Carbon already having, there is no space for the resonance. So last class I told you, for example, CH2 double bond CH3. In this case, resonance is possible. No. For example, in this case, CH2 double bond CH2 plus. In this case, resonance is possible. So means complete cyclic structure, total structure should have the resonance. That's the reason this total compound is non-aromatic. Non-aromatic. Still any doubts, anybody? Obviously, right? If the sp3 carbon means automatically resonance is not possible, right? This is sp2 carbon, right? This is sp3, and there is no vacancy, because when the resonance is possible, for example, you are sitting in this particular chair. Imagine, right, Nana? If the side chair is vacant, then only you can move, right? If in the side chair some people already sitting, can you move? No, that's the reason, because for the migration something vacancy should be there, otherwise it's not possible, right? Planar, oh no, that's only I'm telling, all points. Might be some, this is missing, Hückel's rule is missing, something is missing, right? So we'll discuss in other compounds, right? Right? Dana? Hello. For example, this is the positive charge. Now let me know, compound is cyclic, right? Compound is cyclic, yes or no? Yes. So compound is complete cyclic, resonance is there. So this bond can migrate here, right? So complete cyclic structure, cyclic resonance is there. Resonance, or we could say the conjugation, or right? Conjugation is present. Obviously it is planar. How many pi electrons are there? 2 pi electrons. 2 pi electrons means what? I told you 2, 6, 10, 14, like that. So 2 is matching. So obviously this is what, Nana? Aromatic. So sp3 carbon, there is no sp3 carbon, and already it's a positive charge, right? The positive charge means sp2 carbon. sp2 means planar, and vacancy is also is there. Means resonance is possible. So resonance, first we need to see the resonance, because sometimes minus charge also participating in the resonance. Carbanion, I already told you in the last class. Then, still anybody having any doubt? Hello. We'll do one more compound, one more, right? Negative charge. Now compound is what? Cyclic, yes or no? Is it having the resonance? Conjugation, yes. Planarity, yes, because all are getting the pi bonds, right? Continuous pi bonds. And how many pi electrons? I told you, negative charge also we need, if it is participating in the resonance, we need to calculate as a 2 electrons. It is 2 in the it is 2. Total 4 pi electrons. So when all points, all are means cyclic, resonance, planar, and that is 4 table, 4, 8, right, 12, 16. That is what? Anti-aromatic. This is anti-aromatic. 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 So they'll ask the question like this. They'll give the question option A, option B, option C. Write the stability order. Write the stability order. There's 3 compounds. Write the stability order A, B, C. Tell me. What is the order? B, A, C. B is aromatic, A is non-aromatic, C is anti-aromatic. This is this is aromatic, this is anti-aromatic. Anti-aromatic. Okay. Aromatic compounds means somewhat extra stable. Normal compounds, when we compare with the normal compounds, somewhat highly stable. Non-aromatic compounds means normal molecules, right? And anti-aromatic means highly unstable. Anti-aromatic compounds means highly unstable. Actually, the stability we'll discuss in terms of MOT, molecular orbital theory. The electrons which are present in the bonding molecular orbitals, the compound is more stable, right? If the electrons are present in anti-bonding cases, the compound is unstable. So, but that is not needed here. So, simply try to understand. They follow the 4 rules. So, one compulsory question is coming directly or indirectly. Also, they'll ask the questions. They won't ask you the direct questions. So they'll give you 10 compounds. So they'll ask the numerical type of questions also, right? How many number of aromatic compounds are present? How many compounds are even based on aromaticity? So lot of discussions are there. Lot of questions. Acidic nature we can explain. So those things we will discuss. Right now I'll give you some questions now. Do it right now. So compound is aromatic or non-aromatic or anti-aromatic by your own. Okay? Are you ready? Hello. Yeah. Write it down. I'm giving the numbering also. So board is visible, right, everyone? Right, Nana. I'm just giving you the 11 questions. Hello, completed. Hello. Sona. 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 నేను నెక్స్ట్ క్లాస్ రాలేదు మళ్ళీ. సోనా. ముకుంద్ చేసావా? అయిపోయినాయా? సాయి కంప్లీటెడ్. 9th one. ఓకే. ముకుంద్. చరిత్. కంప్లీటెడ్. Hey, right or wrong doesn't matter. Do something, right? ఖాళీ కూర్చోద్దు. రెండింటిని కౌంట్. 2 పార్టిసిపేట్. చేసేది బెంజిన్ నాన్న ఫేస్ అవుతుంది. రైట్ అన్న. So first one, right? So first one, I already explained this. Cyclic, right? Continuous conjugation is there. Planar, and how many pi electrons? 4 pi electrons. 4 pi electrons means what, Nana? Anti-aromatic. Anti. Clear? So because cyclic, resonance is present, planarity is there, and 4 pi electron. Now in these two cases, year to year resonance is possible. At the same time, year to year also resonance is possible. Yes or no? Right? Total complete resonance is there. So that's the reason cyclic resonance is present, planar is there, and right, 2 pi electrons. Aromatic. Aromatic. Here is also, it's like this also possible, like this also is possible, right? So same, cyclic resonance is there, planarity is also possible, and 2 total 6 pi electrons. 6 pi electrons. So it is also aromatic. Aromatic. Now in this case, continuous conjugation is missing here because of this carbon. So year to year the resonance is possible, but total cycle should present, right? Cyclic. So here is, right, this is non-aromatic. Non-aromatic. Any doubt, anybody? Huh? Enana? మళ్ళీ ఒకసారి అడుగు. Fourth compound is I told you right already. This is sp3 carbon, and resonance is not possible. pH2, two hydrogens are here, right? Total carbon is having the 4 bonds. Hello. Next, fifth one. Fifth one. And all are there, 4 pi electron. This is anti. Sixth one. There's 2 to total 6 and complete right conjugation is there, cyclic, planar. So this is aromatic. The benzene. So one of the benzene is aromatic compounds, means the brand ambassador is benzene. For aromatic, right? For aromatic compounds, brand ambassador is benzene. So cyclic resonance is there, right? Everything is present, right? So this is aromatic. 6 pi electrons. Cyclic, planar is a perfect example for the benzene. Benzenoids, the benzene structure. Right. In this case, same thing is happened, right? This is missing, so total complete conjugation is not present. This is non-aromatic. Non-aromatic. Right? Hello. Next, Nana. Ninth one. Ninth one. Anyone? Ninth one. Right? Aromatic, cyclic, aromatic. Right? Tenth one. Tenth one. Anti-aromatic. So 11th one is important. Actually 11th one seems to be anti-aromatic, but it is non-aromatic because this is tub shaped runner. Actually it is non-planar. So it's like a tub shaped structure. Non-planar. It seems to be anti-aromatic, but is not anti-aromatic because it's non-planar. The structure is not in the plane. It's like in a tub shape. So that's the reason this is, we could say simply non-aromatic. Important one, Anna. So a lot of students will confuse in this particular case because it seems to be anti-aromatic, right? But it's not anti-aromatic. This is non-aromatic because of its tub shape. Done, everyone? Any doubt? Then write fast. This is where called as furan. Furan means what? Heterocyclic compound. Homocyclic and heterocyclic two compounds are there. If in the carbon in the cyclic ring, all are carbons. That is homocyclic. In the along with any oxygen, nitrogen, along with carbon, oxygen, nitrogen, sulfur. If anything is coming, that we could say hetero compounds. Hetero. is also heterocyclic compound. Lone pair also participating in the resonance. Hetero means along with carbon, one hetero atom like oxygen, nitrogen, sulfur. Okay. Homocyclic means all carbons, only carbons like benzene is there. In this, these are homocyclic. All are carbons, right? Come on, do this. Do this. Come on, do it fast. Then completed. Hmm? Completed. So first one. Hmm? So 12th one. Who will tell? Hmm? 12th one. Pranay. Pranay. 12th one. Hmm. So this is cyclic, right? Both are cyclic. Continuous conjugation is present. Total how many pi bonds, Nana? Right? Total 5. 5 into 2, 10. So 10 pi electrons. So this is aromatic. 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 Green color బాగా కనిపిస్తుందా? Hello. So 10 pi electrons. అంత బాలేదా? Okay. So this is naphthalene. Naphthalene. Naphthalene balls we are using, right? Where we are using the naphthalene balls? In clothes and washrooms. So that's naphthalene balls, that is. This is anthracene. So how many pi electrons here is total? 4, right? 14 pi electrons. 7 bonds. 7 into 2, 14 pi electrons. It is also aromatic. It is also aromatic. It's a furan, no? This lone pair is also participating in the resonance now. So lone pair means with negative charge like this. Is a 2 pi electrons. Total 6. Cyclic, right? Planar, having the resonance and 6 pi electrons. So this is also aromatic. Same. This is also aromatic. 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 This is also, here is one of the important thing. This lone pair is there, don't calculate, right? Only these 3 only we need to calculate. So some people, sir, you are calculating this, right? This total along with this is 2, 2, 2, total 6. Here is, if you are calculating these 2 electrons, it would be 8, right? But 8 means anti-aromatic, right? So because it's not participating, no need. So electrons, right? Resonance is taking place, which is needed, which is important for us. Hello. So this is not participating in the resonance. Total 6 pi electrons only. Aromatic. Aromatic. Done? Hello. Well, 17. This is above, above the plane oxygen. Above. This is total planar. This white color is total planar. So oxygen is above, like pyramid shape like this. That's the reason I just right. Yellow color I shown. Here is also nitrogen. This arrow I'm putting means the above here will get the negative charge, here will get the positive charge. Down. Right. Right or wrong doesn't matter, okay? Anish, అర్థమవుతున్నాయా? సాయిరితిక్ యూట్యూబ్లో వస్తుందా చూడరా? నీకు ఒక్కనికే దొరుకుతుందిరా, లింక్ ఎవరికి దొరకట్లేదు. దొరికిందా నీకు? వెళ్ళి చూసావా ఇంటికి వెళ్ళి? సరేనా? కంప్లీటెడా? సరే చేసావా ముకుంద్? యా, వస్తుందా? చూసుకోండి మిమ్మల్ని మీరు కూడా యూట్యూబ్లో. we are also upgrading, like live streaming along with our name. Yeah, first one, this is very important. In this case, because of two hydrogens, flagpole hydrogens, the repulsions are present now. Because of these two hydrogens repulsions, right? These two hydrogen repulsions, the total molecules goes to the out of plane. Out of plane. So means obviously it is, when it is going out of plane, this is non-aromatic now. Non-aromatic. So because of hydrogens, it goes out of plane, right? Out of plane. Because of fighting with these two hydrogens. Fighting with these two hydrogens, we could say the flagpole hydrogens. The flagpole hydrogens are coming closer, fighting, dishum, shallow. So you are that side, I am going to this side, so automatically the molecule goes to the out of plane. So non-planar, so obviously non-aromatic. And in this case, here is oxygen, only one oxygen is there, so it is not disturbing the total this process now. The electrons, right, can migrate here to here, here to here. So in this case, it's fine, right? Resonance is possible, it's not disturbing. So total 1, 2, 3, 4, 5. So it's aromatic. So moving forward, this is also same like, because the nitrogen is goes up, the total down, what the white color bonds are in the same plane, right? Because of the same plane, this is also aromatic. Usually a lot of students are thinking this is, right, non-aromatic, but it's not non-aromatic, it's aromatic. It is also aromatic, very important. But the problem is with this molecule. In this category, this is one of the important thing. Because of hydrogens are fighting with each other, so they'll go out of plane. And one more important thing is here, this one, right? The above arrow, that indicates us what, Nana? Huh? This above arrow indicates us what? Huh? So above is negative charge, below is positive charge. We need to separate it both. Okay? Total, just separate it. So see above and below. So above negative charge, below positive charge. Tell me. Hello. So right here, one more important thing, Nana. So if in a molecule, two compounds are, two rings are present. So this combination is there. If one is aromatic, other one is also aromatic, the resultant compound is aromatic. Write it down. One is aromatic, other one is non-aromatic. The resultant compound, we could say the aromatic. One is aromatic and the other one is anti-aromatic. The compound is non-aromatic. So one is anti-aromatic, one is non-aromatic. This is anti-aromatic, right? Anti-aromatic plus anti-aromatic, anti-aromatic, anti-aromatic. Okay, now this is above case. What is aromatic or anti-aromatic? Hello, aromatic or anti-aromatic? This is anti. Down one also anti. Anti. Total compound is anti-aromatic. Anti-aromatic. Clear? These are the combinations, because anti, both are anti-aromatic. Then Pranay, take screenshot. మళ్ళీ ఎటు నువ్వు రాయవు. హైరీతికి దొరికిందా? ఇక్కడ నేను కొంచెం చార్ట్లు చదివేటట్లేదు, పక్కనకి వెళ్ళి చూడండి. Then this one, 22. 22. So here is positive charge, here is negative charge, right? So positive charge means, like, don't confuse now. This is above one is this type of structure. The first compound we did, right? This is aromatic, this is also aromatic. Aromatic plus aromatic, total aromatic. Aromatic, aromatic, total, and right, aromatic. Done now? Done now? Page ఖాళీ ఉంది. ఎంత 22 కదా, 23. సాయి చేస్తున్నావా? Any doubts? They are called as benzene. So it's I'm starting from 5th అనుకుంటున్నాను. 145 days crash course for JEE mains coming January session. Right? Any of your friends? ఓకేనా? టైమింగ్ చెప్తాను నేను, మన టైం క్లాష్ అవ్వకుండా చూద్దాం. వాళ్ళు వచ్చి జాయిన్ అయిన బట్టి ఆఫ్టర్నూన్ ఆర్ మార్నింగ్ మొత్తం ఫాస్ట్ ట్రాక్లో వెళ్ళిపోతుంది. ఆర్గానిక్, ఇన్ఆర్గానిక్ మనం అంటే ఆర్గానిక్, ఇన్ఆర్గానిక్ ఇక్కడ అయిపోతుంది. అది ఫాస్ట్గా వెళ్ళిపోతుంది, ఫాస్ట్ ట్రాక్లో వెళ్ళిపోతుంది. కంప్లీట్గా. హలో, స్ట్రక్చర్సే ఇస్తున్నారా? This structure is wrong, sorry. Right, Nana. So the first one, negative charge, here is positive charge. Aromatic, aromatic. Total compound is aromatic. Yes, Nana. Aromatic, aromatic, right? This is right anti. Both are anti. Anti. So total anti-aromatic. This case, this is anti, this is anti, this is aromatic. Total anti-aromatic and anti-aromatic, non-aromatic. Non-aromatic combinations. This is aromatic, anti-aromatic, non-aromatic. So the benzene is important. Let me know what is benzene. Benzene is unstable, of course, but seems to be aromatic or non-aromatic or anti-aromatic. Hello. Non-aromatic, aromatic, non-aromatic. Anyone? Try. Mukund, Avikshit, Sona. Aromatic, Nana. So it's not participating in the resonance. Only these three are participating. Aromatic. So here is a lot of things are there. Based on this, right. So once again, I'll just revise all starting onwards. So the total items, first aromatic compounds, anti-aromatic. So aromatic compounds are more stable than non-aromatic than anti-aromatic. Means highly stable, normal molecules highly unstable, right? Whenever they are asking the stability orders, so we need to cross check whether that is aromatic or non-aromatic or anti-aromatic. Next, for aromatic compounds, I told you compound should be cyclic, it should have the resonance, and it should be planar, right? It should obey the Hückel's rule. So 4n plus 2 pi electrons. And anti-aromatic cases also same thing, but only the difference is 4n plus 2, here only 4n pi electrons. And so what is exactly Hückel's rule? Means 4n plus 2 pi electrons, if n is equals to 1, 2, 3, 4, if n is equals to 0 means 2, n is equals to 1 means 6, 10, 14. So just remember 2, 6, 10, 14. And in case of anti cases, 4 4 pi electrons. 4 pi electrons means what? 4 table. 4 table. Just keep in your mind 4 table is there, that is anti-aromatic. 4 ones are 4, 4 twos are 8, 12, 16, 20 like that. Okay now? This is 4, 8, 12, 16. This is anti-aromatic along with all. So these compounds now only we discussed. So obviously these compounds. So moving forward, this is the first example which we did. Aromatic compound, anti-aromatic compound, and a lot of examples we discussed. Heterocyclic compounds, these are heterocyclic compounds. And these compounds aromatic, non-aromatic and anti-aromatic. And one more important thing, for example, I told you alkenes undergoes which type of reactions? Alkenes undergoes which type of reactions? Anyone? Electrophilic addition reaction this is, right? So the double bond becomes single bond. The double bond becomes single bond, electrophilic addition reaction. Imagine, no? They'll ask a question, why benzene does not undergo addition reaction, electrophilic addition? So if here is also same bond is there, right? HBr. So now in this case, sir, here is the double bond, here is the double bond is there, here is also double bond. So is this reaction takes place or not? Is this reaction takes place or not? Not takes place. Why? Right, this is aromatic compound, this is non-aromatic compound, right? Aromatic compound is more stable. So any person wants to lose their stability? No, right? So that's the reason someone if was asking why benzene does not undergo addition reactions. So what is the answer you have to say? Benzene, if benzene undergoes addition reaction, it loses its aromatic nature. So if it's losing aromatic nature, compound is what? Compound is non-aromatic means unstable, stable to unstable. So that's the reason benzene generally undergoes substitution reactions. What exactly substitution? In case of substitution, hydrogen is here. For example, if I am electrophile substitution takes place. Here is the electrophile substitution, but we are not disturbing the benzene ring. We are not disturbing the benzene ring. So next class I'll ask, benzene undergoes electrophilic substitution reactions generally. Why benzene generally does not undergo nucleophilic substitution? Why? One more question is coming. Benzene favorite what? Benzene favorite is electrophilic substitution. So why benzene does not undergo nucleophilic substitution? Here we are not disturbing any benzene ring, we are not disturbing. But what exactly happened? Benzene is above and below, the negative charge is there, negative charge, what happens? What happens, Nana? Repulsions are there. Because of that repulsions, benzene does not undergo nucleophilic substitution. But it is undergoing some extreme cases. So every time chemistry is having its own exceptions. Okay. Every time, because I generally won't say any lies, but sometimes I used to lie. It depends on situation, right? So like that. This is one of the important why benzene does not undergo addition reactions, means it's losing its stability. One of the important application. And tomorrow we will discuss some more applications of aromatic compounds, and so some advanced level we will discuss. So this is a basic level only, the level 1 which I am discussing. The second applications we will discuss tomorrow. Okay na? So for ionic equilibrium, so just stay tuned. So we'll start. Atlane undandi, right? For ionic equilibrium we'll start. లైవ్ అట్లనే కంటిన్యూ కానిద్దామా? Right, Nana. So is it audible, right, everyone? Hello? Right. So last class what we were discussing, Nana? Buffer solutions, right? What is buffer? When we are adding some small amount of acid or base, there is no change in the pH, right? So we have acidic buffers, basic buffers. Acidic buffers means what? Acidic buffers means what? Right? So weak acid, mixture of weak acid and its salt of strong base. So this is the acidic buffer mixture. Acidic buffer mixture. Okay? Acidic buffer mixture. ఇది కూడా అది రెండు సేమ్ చేయలేదా? సేమ్ చేయలేదు, వెనక కూడా సేమ్ చేయాలి. సినిమా హాల్కి పోతే ముందర కూర్చుంటాం, ఇది సినిమా లైక్ ప్రొజెక్టర్ కదా. రైట్. సో వీక్ యాసిడ్ అండ్ ఇట్స్ సాల్ట్ ఆఫ్ స్ట్రాంగ్ బేస్. సో వాట్ ఎగ్జాక్ట్లీ ద బఫర్ మెకానిజం నన్ను? When we are adding some small amounts of acid and base, there is no change in the pH, right? Hello. It's a weak acid, right, Nana? Weak acid means degree of dissociation is more or less. So salts, I told you, salts are acts as a strong electrolytes. 100% dissociation takes place. CH3COO Na is gives rise to CH3COO minus Na plus. Now this is the reaction mixture. When we are adding some small acids, right? For example, it's Cl. If I am adding 10 molecules of 10 ions H plus, I am adding automatically because of common ion effect. Common ion effect, what happens? H plus ion concentration increases in the product side. The reaction moves to the backward direction. So for example, we added 10 H plus ions, there is no change in the H plus ion concentration. Automatically, there is no change in the pH. If you are adding some small amounts of base, what exactly happens, Nana? The base OH minus will combine with H plus. What neutralization is takes place? Automatically, H plus ion concentration is decreases. Then forward reaction is taking place, right? Because of forward reaction, what exactly happens? So there is no change in the H plus ion concentration. There is no change in the pH. Yes. So how to calculate the pH for acidic solutions? pH is equals to what, Nana? pKa plus log salt concentration by acid concentration. Salt concentration by acid concentration. pH is equals to pKa plus log salt concentration by acid concentration. So weak acids, and I gave you different examples yesterday. Let it know. Any doubt in this particular case? Hello? Yes, Nana. ఇక్కడ ఏం అర్థగలరా నీకు? So what I'm trying to say is, this is a total buffer solution mixture, right? Hello. So now what is buffer? What is buffer? When we are adding some small amounts of acid or base, there is no change in the pH. So for example, if you are adding some acid, right? For example, 10 H plus, 10 HCl or H plus ions are adding, right? So automatically it is H plus ion concentration 10 or increases, right, in the product side. According to Le Chatelier principle, the concentration of H plus ions are increases, right? Hello. So then automatically what happens? Which reaction takes place? Backward reaction. So the H plus is combined with CH3COO minus, it becomes CH3COOH. There is no change in the H plus ion. For example, if you are adding 10 H plus ions, the 10 H plus ions are coming towards the back side, right? Backward direction. So there is no resultant, there is no change in the H plus ion concentration. So means there is no change in the pH. Okay. Hello. So exactly if we are adding the OH minus, for example base, NaOH or something, what exactly happens? The OH minus will take the H plus, right? Neutralization reaction takes place. H plus and concentration decreases in the product side. So then forward reaction takes place. This is the equilibrium, right? How many H plus ions are decreased? That many H plus ions are compensated by this CH3COOH. So then there is no change in the H plus ion concentration. There is no change in the pH. Okay. Hello. Yeah. Write a question. 12 grams of CH3COOH, 12 grams of CH3COOH and 16.4 grams of 16.4 grams of 12 grams of right? 12 grams of CH3COOH, 12 grams of CH3COOH and 16.4 grams of CH3COONA, H3COONA are dissolved in 1 liter of water, or dissolved in 1 liter water, 1 liter water, right? 1 liter of water. Ka of CH3COOH is given, Ka of CH3COOH 10 to the power of minus 5, 10 to the power of minus 5, Ka. Calculate the pH of resulting solution. Question number 1, calculate the pH of resulting solution. Calculate the pH of resulting solution. Calculate the pH of resulting solution. What is the answer, Nana? What is the answer? Tell me. Anybody got the answer? 5. 5 is the right answer. So already I told you, right? What is the formula now? pH is equals to, right, pKa is log, right, salt concentration by acid concentration. Concentration, what is concentration? Concentration, number of moles, right, by volume, liters. So same volume is same. So it is CH3COOH. What is its molecular weight? 60. So 12 by 60. How much? 12 ones are 12, 5 are 0.2. And CH3COONA. CH3COONA. How much, Nana? 16.4 by molecular weight is how much? 82. 82. Okay. So approximately it is also 0.2. Put the values here. pKa means 10 to the power of minus 5, means 5 directly. Log 0.2 by 0.2 means 0.1. 10 to the power of minus 1 means what? Huh? Log 0.2 means cancel 1 means 1 simply directly you can log 0.2 with 0.2 directly you will get answer. Simple. So see the calculations whenever they are giving that in easy mode. Cancel అయిపోతాయి కదా అందుకోసమే సేమ్ వాల్యూమ్ రైట్. So actually level we can increase the level but I'm not increasing. Okay, so like this some questions. Next no, put the heading basic buffers. Basic buffers. Basic buffers. Weak base. Weak base. Basic buffer. Weak base plus its salt of strong acid. Its salt of strong acid. The important example NH4OH for example if I am taking this NH4OH plus NH4Cl. Weak base and its salt of strong acid. Its salt of means I already told you NaOH, right? NaOH strong base plus NH4OH, NH4OH plus HCl strong acid. You get NH4 salt of weak base and strong acid. So it's also its mechanism also same thing. What is a basic buffer? When we are adding some small amounts of acid and base, there is no change in the pH. Okay. అర్థమైందా? Right now. So NH4OH gives rise to weak base, right? NH4 plus OH minus. NH4 plus OH minus. NH4Cl gives rise to NH4 plus Cl minus. So same thing. This is the reaction mixture vessel. So Pranay, tell me, if I'm adding some small amounts of acid, what exactly happens? What exactly happens? If I'm adding some small amounts of acid, what happens? For neutralization, there is no change in the OH minus ion concentration. If there is no change in the OH minus, there is no change in the POH. If there is no change in the POH, there is no change in the pH. pH plus POH is equals to 14. If you are adding some base, OH base adding, so OH minus ion concentration is increases. Because of common ion effect, reaction moves backward direction. Same as it is. Okay? Hello? So salt aim plays because these ions are 100% dissociation. This total mixture, because it acts as a common ion effect and all, right? Right. So for POH in this case, for basic buffers, what we need to do? POH. Directly write pKb plus log salt concentration by base concentration. So there is acid concentration Ka, right? pH is equals to what, Nana? pKa plus log salt concentration by acid concentration. In this case, base concentration. Come on, write it down. So I'm not telling the derivation. Shall I explain the derivation? No need, right? Shall I explain derivation? No need, right? Same. Otherwise, we'll do. Right one. NH4OH gives rise to NH4 plus OH. Step we know, right? For Kb, how we'll write? Kb is equals to NH4 plus concentration OH minus ion concentration by NH4OH concentration. So what we need to calculate? POH, right? OH will write outside. OH minus ion concentration is equals to Kb into NH4OH concentration by NH4 plus concentration, right? So apply the log both sides. So minus, directly I am applying the minus log, right? Minus log OH minus ion concentration is equals to minus log Kb. Actually, first we need to apply the first normal log and we need to multiply with the minus 1. Directly I am doing, right? Minus log, here is what? Base concentration by base by salt. Actually, first salt is coming down because the negative charge. So now POH is equals to PKB. So if you are writing the minus, means base by salt concentration we can write. For example, if I am writing the positive charge, means salt is, right, log salt concentration by base concentration. If they are asking base is given, so pH plus POH is equals to 14. pH plus POH is equals to 14. Basic buffer. Then next, no, put the heading buffer capacity. Buffer capacity. Buffer capacity. So write it down. It's denoted with one term then phi. Denoted with phi and defined as the amount of strong acid or strong base. The amount of strong acid or strong base. The amount of strong acid or strong base. The amount of strong acid or strong base which should be added in 1 liter of buffer solution, 1 liter of buffer solution to change its pH, to change its pH by 1 unit, by 1 unit. So dx by dpH equals to 2.303, 2.303 AB by A plus B. So just write it down this. Statement. So ఏమని చెప్పినా నేను? So it is defined as the amount of strong acid or strong base, okay, which should be added in 1 liter of buffer solution, 1 liter of buffer solution. The amount of strong acid, it is defined as the amount of strong acid or strong base, amount of strong acid or strong base which should be added, in 1 liter of, it should be added 1 liter of buffer solution to change its pH, by 1 unit, to change its pH by 1 unit. Okay. So it is, what is dx, Rana? Dx is equals, write it down, dx, the amount of acid or base added, dx is equals to the amount of acid or base added, the amount of acid or base added. dpH means, change in the pH, change in the pH, right? And what is A or B? A is equals to concentration of acid or base. A is equals to concentration of acid or base, concentration of acid or base. B is equals to, tell me, concentration of salt, concentration of salt. Done, Nana? Write a question, one more question. Calculate the pH of buffer solution containing, calculate the pH of solution, calculate the pH of buffer solution containing 0.2 mole of 0.2 mole of NH4Cl NH4Cl polarity కాదు మోల్ అని రాసుకో 0. mole of 4Cl NH4Cl and 0.1 mole of NH4OH NH4OH per liter solution. Kb equals to 1.85 తీసుకోండి 1.85 into 10 to the power of -5. Easy question, do it now fast. So what I am asking, calculate pH, not pOH. అదే అందుకోసం ఫాస్ట్ చేసి రాంగ్ చేయొద్దు. ముకుంద్ చేసావు నాన్న? ఫస్ట్ ఒక లెవెల్ చేయండి, తర్వాత రెండో లెవెల్కి ఆటోమేటిక్గా వెళ్ళిపోతారు. చూడు ఎట్లా నీకు ఎట్లా అనిపిస్తుంది. Then run. What is the answer got? 8.9 approximately. 8.9. Exact values approximate తీసుకోవచ్చు of course. ఇప్పుడు 1.85 into 10 to the power of minus 5 ఎంత వస్తుందిరా log? 1.85. So log 2 is how much? 0.3, right? Log 1.86 means approximately how much we can take? 1 point? So directly we'll get 4.7. So what is the pH? POH is equals to, right? So pKb plus log salt concentration by base concentration. So it is 1 point. Look, Kb is given, right? How much now? pKb equals to minus log Kb minus log 1.8 into 10 to the power of minus 5. So 5 minus 1.8 approximately 0.8 means approximately you can take 0 point, right? 0.3. So 1.8 is nothing but what? Approximately, right? 0.3. You can take 4.7 something, right? So 4.7 plus log salt concentration is how much? 0.2 by base concentration 0.1, right? Log 2 0.3, you get approximately 5. Approximately, if it is very close, then you can do the total calculation. So here is they'll ask in different modes of questions. Shall we do one more question? ఏమంటున్నావు? Write one more question. How much CH3COO Na? How much CH3COO Na? How much CH3COO Na should be added to 1 liter of 0.1 molar CH3COOH. 0.1 molar of CH3COOH to make a buffer of pH is equals to 4.0, 4.0, right? Ka is equals to 1.8 into 10 to the power of minus 5. So what we need to find in this case? Salt concentration. So everything is given. pH is equals to pKa S log salt concentration by acid concentration. So pH is given, pKa is given, acid concentration is given. Okay, so we need to find out. We need to find out salt concentration. Okay. pK. ఏమంటున్నాను? pH అవును. ఓకే. ట్రై చేయి, ఏం రాదు. సో మీకు ఆన్సర్ ఎంత వస్తుందంటే అప్రాక్సిమేట్గా చెప్తున్నాను నేను. 1.8 into 10 to the power of -2 mole per liter. 1.8. This is the answer. 1.8 into 10 to the power of right. అదే రా, మళ్ళీ ఒకసారి చెయ్యి. 10 to the power of -2 ఉంది. నెక్స్ట్ ఒకటి ఏంద్రా, లాస్ట్ టాపిక్ సాల్యుబిలిటీ ప్రోడక్ట్. ద సాల్యుబిలిటీ ప్రోడక్ట్ ఐ విల్ డిస్కస్ టుమారో, రైట్? ఈజీగా ఉంటుంది లాస్ట్ సాల్యుబిలిటీ ప్రోడక్ట్స్. దెన్ రైట్ రా. I told you today I'll start that ఏదైతే approximate pH of the salt. partial pressure ఇచ్చిండు. ఇంకోటి క్వశ్చన్ ఏంటి డౌట్ ఏంటి? ఏముంటుంది ఈజీ క్వశ్చన్, రెండు యాడ్ చేయి, తర్వాత బేస్ తోటి మిల్లీ ఈక్వలెంట్స్ తీసుకో, మిల్లీ ఈక్వలెంట్ సపరేట్ చేసే తర్వాత లాస్ట్ రిజల్టింగ్ సొల్యూషన్ ఎసిడికా బేసికా వస్తుంది. దాని నుంచి మనం సో హౌ మెనీ ఆఫ్ యూ నో కైనటిక్స్ నానా? హలో, సొల్యూషన్స్ రైట్ నాన్న, audible right? Hello, is it audible right? Yeah, hello, yeah. So kinetics nana, so chemical kinetics, we know thermodynamics, right? What exactly the thermodynamics deals with? Thermodynamics, thermodynamics deals with what nana? Feasibility of a reaction. Feasibility means what? Whether the reaction takes place or not. Whether the reaction takes place or not. Once the reaction is taking place, then next what we need? So thermodynamics won't speak anything about the mechanism, and thermodynamics won't speak anything about the rate of the reaction, right? For example, last class I told you somewhat. For example, I want to give you 1 crore rupees each one. Okay, the first one you people estimate, is it possible or not? Is it feasible or not? For example, 10 members are there, 10 members are 10 crores, might be SAR is not having, so it's not possible. Okay, might be it is possible. Who are telling the possible or not? Thermodynamics is telling. Then afterwards, what is the question you people will ask me? Obviously, when you will give. The time is important. Time is also very important. I'll give you after 20 years. Means what? Sir, after 20 years, we will go grown up and we only give you the back. So no need, right? Time is very important. The chemical kinetics, what we will discuss? Rate of reactions particularly, right? Mechanism of the reactions. We know SN1 and SN2, what is the mechanism? So, and in this case, factors affecting the rate of reaction. Which factors are affecting, right? Surface area increasing, concentration of reactant increasing, so what is the collisions, temperature effect, right? With the temperature increases, rate of reaction is increases. Catalyst effect, when we are adding the catalyst, what exactly happens? Speed of reaction is increases, right? So based on temperature constants and Arrhenius equation we will discuss, right? So, and here is order of the reactions, 0 order, first order, second order, rate law, rate expression. Whenever I'm explaining that chemical equilibrium, so according to law of mass action, whatever the coefficients I discussed over there, but in this case rate law and rate expression is important, right? So particularly rate of reaction, speed of the reaction we will discuss, and how many types of reactions are there. Reactions are, right, we are just classifying 3 types: very slow reactions, moderate reactions, and very fast reactions. Very fast means instantaneous reactions. Instantaneous means what? Very fast, fraction of seconds. For example, acid and base, if you are adding, automatically what exactly? Fraction of seconds, so neutralization reaction takes place, right? And redox reactions, right? So some also very fast, instantaneous reaction. So then moderate reactions, whatever the reactions which we are discussing are moderate reactions, like Riemann-Tiemann reaction, Cole-Base reaction, HVZ reaction. Normal reactions, whatever the organic chemistry reactions, all reactions are which reactions? No, moderate reactions. Moderate means 2 to 10 minutes or 1 day, that doesn't matter. But very slow reactions. Very slow reactions means what? Very slow. Rusting of iron, for example. So put some iron outside and see how much time it would take to rusting. So if you keep on waiting, it might be take 1 year, 2 years, 3 years, 6 months. If you are well painted, right? Won't take, because very slow reactions. We can't wait for 2 years. We can wait hours, 1 hour, 2 hours, 3 hours, or 10 minutes, 15 minutes we can wait. So that is moderate reactions. Particularly, we will study generally moderate reactions, not generally very slow and very fast, or instantaneous, instant coffee like that. Okay. So in this chemical kinetics, rate of reaction is important. So factors affecting the rate and order of the reaction. Order and molecularity, one more topic we will discuss. Order, 0 order, first order, second order, right? Third order, up to third order is there. 0 order, first order, second order, third order. SN1 reactions undergoes which type of reactions? SN1, unimolecular nuclear. Molecular, but order what I am asking. First order. SN2, second order. E1 reaction, which order? E1. Online guys. E1, first order. E2, second order. What is first order? Difference between first order and second order? If the concentration increases, for example, if the concentration increases, rate also same increases. For example, I am doubling the concentration. Rate also doubles. So, for example, A gives rise to product. So rate is equals to K power 1. 1 means what? First order reaction. If I am increasing the rate double, automatic concentration also doubles. If I am increasing the triple, right? Those things. If it is second order, rate is directly proportional to K A power 2, right? If I am double, rate is increasing. So 2 times if I am increasing, it's 4 times. Yes or no? Double. Power is there. So those things means 0 order we will discuss. First order, mainly 0 order and first order are very important. Based on, because in our syllabus 0 order and first order is there. First order and factors affecting these things, right? So step by step, I'll explain only important major focus areas. Hello. So put that in chemical kinetics. E1 first order. అవి వేరు మళ్ళీ చాలా ఫ్యాక్టర్స్ మీద ఉంటుంది. ఆర్డర్ వాట్ ఐఎమ్ స్పీకింగ్. చాలా ఫ్యాక్టర్స్ ఉంటాయి, బట్ వాట్ ఎగ్జాక్ట్లీ ద ఆర్డర్ we will discuss, because 0 order, first order, and both rate of reaction and temperature effect, catalyst. So these only the important thing, Arrhenius equation. And zero order, first order is main things which we have to discuss in the kinetics. Kinetics means particularly speed, rate of reaction, right? How much speed is reaction takes place, right? Which order it would be. So what is the catalyst effect? What is the temperature effect on the rate of reaction? And mechanism. So but thermodynamics won't speak anything about the rate of reaction and mechanism, but kinetics will speak all these things. Okay, first try to understand why we need to study the chemical kinetics. Kinetics, right? Yeah. Hello, Nana. So put the heading, just write the definition for the chemical kinetics. Chemical kinetics deals with the rate of reaction, and various factors that influence the rate of reaction. Various factors that influence the rate of reaction. Various factors that influence the rate of reaction. And also mechanism of the reaction. And also mechanism of reaction. And also mechanism of the reaction. So means totally in kinetics this is the thing. So factors affecting the rate of reaction and the mechanism of the reaction. Okay, this is I told you. So rate of reaction we will discuss, nothing is the rate of reaction and order of reaction and factors, mechanisms, which direction reaction is takes place, which type of collisions are takes place, what exactly happens, we will discuss. So write it on one more point. Depending upon the rate of reaction, reactions are classified into three types. So first one is very fast or instantaneous. Very fast or instantaneous. Write it down. These reactions are completed in fraction of seconds. These reactions are completed in fraction of seconds. Fraction of second. Right, one more important. All ionic reactions are very fast reactions. AgCl is NaNO3. So when we compare with covalent and ionic reactions, so why ionic reactions are very fast? This is very fundamental question. So in case of covalent bond, we need to break the bond. But whereas in case of ionic bond, no need to break, because only attractions are there. NaCl is there. For example, NaCl is there. Directly we can, no need to break. Attractions only, right? Right. So BaCl2. Write some example. BaCl2 H2SO4. Write it down. BaSO4 repetition rate. BaSO white color repeat. 2 moles of HCl plus NaOH. Neutralization. HCl plus. Very fast. Next, very slow reactions. Put the heading. Very slow reaction. Very slow reaction. Very slow reaction. Very slow. For the completion of these reactions, very long time period is required. For the completion of these reactions, very long time period, very long time is required. Right. Example, I already told you. What is example? Rusting of iron. Rusting of iron. P plus O2 gives rise to CO2. P plus O2, room temperature. If it is happening now, what happens? At the room temperature, it is very slow reaction. If this reaction occurs very fast, what happens? CO2 increases. When the CO2 increases, what happens? Global warming. If the global warming is coming, that will sink. So means these reactions won't happen. Plus H2 plus of O2 gives rise to H2. If this reaction is happening, come on, mix hydrogen and oxygen, so we'll get the water, right? At room temperature, generally it's very, for a glass of water we need to wait long time, right? Next, moderate reactions. Put that in. Moderate reactions. Moderate reactions. These reactions are completed in few minutes or few hours. Few minutes or few hours. Few hours అన్నాను. అవర్స్లో అంటే 24 hours కూడా ఉండే కిందకి వస్తుంది. అదేమో ఇయర్స్ అని చెప్పా. H2O plus. These reactions will complete in few minutes or hours అని చెప్పా. Few hours. For example, esterification reaction. What exactly happens? CH3. So, esterification. So, whatever the normal reactions we are discussing. What is Riemann-Tiemann reaction? What is the Riemann-Tiemann reaction? Orthohydroxy benzaldehyde, parahydroxy benzaldehyde. Orthohydroxy benzaldehyde, parahydroxy benzaldehyde. So any reaction, carbylamine reaction. What is carbylamine reaction? It is in all N2O5. N2O5. 2NO2 plus of O2. 2NO2 plus of O2. Right? So this is the just types of reactions. Put the heading rate of reaction. Rate of reaction. Rate of reaction. Rate of reaction. Rate of reaction is equals to rate of reaction. So for example, try to understand reactants are converting into products. At time t is equals to 0. For example, reactant is more, 100 is there. So product is 0. So speed, how can we define the speed? Speed, for example, the vehicle is moving 100 km per hour. Speed, how can we say? Distance by displacement by time. Speed of the physics, right? Here is reaction. So time t is equals to 100 per 0, 100. What exactly after time t? For example, after 10 minutes. After time 10 minutes, what exactly happens? Might be this is 80, 20. For example, after 20 minutes or 20, right? So it would be 60, 40. Right? What exactly happens here? Rate of the reaction means what? Change in concentration. Change in concentration. Change in concentration by time taken. Write it down. Change in concentration by time period or time taken. Time period or time taken. Change in concentration by time taken. One more important thing we can observe over here. After time is increasing, what about the reactant concentration? Decreases. What about the product concentration? Increases. So we can change the rate of reaction is equals to, right? Rate of reaction, not RR. Rate of reaction. So what we can write? Decreasing in the concentration of reactants by time taken. Write it down. A time period or time taken. Decreasing in concentration of reactants by time taken. This is rate of reaction formula. Rate of reaction. Or we can write what? Increasing the total rate. Increasing the concentration of products. Increasing the concentration of products. Increasing the concentration of products. Increasing the concentration of products by time taken. Right. For example, here is the concentration if I am taking time. Right? Concentration. First reactant concentration is high, right? After time keep on increasing, what exactly happens? Concentration is keep on decreasing. The products first 0. So we keep on increasing. Write it down. This is reactant. Product. Here is two types of rates are there, average rate and instantaneous rate, right? Average rate, instantaneous rate. తగ్గుతా పోతా ఉంటుంది అన్నట్టు అర్థంగా జస్ట్ నేను నార్మల్గా వేసాను. Average rate of reaction. Average rate of reaction. So rate of reactions are two types, average rate and instantaneous rate. Average rate of reaction. Average rate of reaction. Delta x by delta t. X2 minus x1 by T2 minus average rate. So average rate, for example, A to B products, if you are writing A to products, how can we write A at time T2, A2 minus A1, right? T1 concentration by change in the time T2 minus T1. Concentration, change in the concentration. A delta A we can take, right? Delta A gives it. So here is simply delta T value we can calculate. It is in the minutes. For example, if delta T tends to 0 means what? Change in the concentration. For example, here is 5 minutes we are calculating. 5 minutes or 10 minutes means we can calculate. Within fraction of seconds, in fraction of tends to 0 point in fraction of seconds. So that we are called as instantaneous reaction. Write it down. Instantaneous rate of reaction. Instantaneous rate of reaction. Instantaneous rate of reaction. Instantaneous rate of reaction. Instantaneous means what? When delta T tends to 0. Delta T tends to 0. When delta T tends to 0, the rate of reaction is called instantaneous reaction. Instantaneous reaction is equals to instantaneous rate of reaction equals to instantaneous rate of reaction is equals to what we can write? Limits delta T, delta X by T, right? Limits delta X by delta T at delta T tends to 0, then becomes dx by dt. So where is dx by dt? Delta D. So only the small difference. Average rate and instantaneous rate. What is the difference? In average case, delta. Instantaneous case is D. So generally, Nana, for example, A plus B, A gives rise to something B. Gives rise to B. A gives rise to B. So generally, how can we write average rate? Minus delta A concentration by delta T. We can write this rate of reaction is equals to change in the concentration, I mean decreasing the concentration of reactant. Here is the minus sign that indicates decreasing the concentration, not that, right? Or equals to, we can write plus delta P by delta T. Positive means product is increasing. Negative means product is decreasing, but not the normal mathematics signs. Then minus sign means write it down. Here is minus delta A by delta T. Right. What is that? Rate of, so means a rate of disappearance of A. So the same thing, Nana, if we are writing the same equation in terms of instantaneous rate, what exactly happens? Instantaneous rate. We want to write the same equation in the instantaneous rate. Minus dA concentration by dt equals to plus dB concentration by dt. Right. Minus dA concentration by dt. What is this meaning? Write it down. Minus dA concentration by dt. Write it down. Write it down. Minus dA concentration by dt is called rate of consumption of A. 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 Or rate of disappearance of A. Or rate of disappearance of A. Rate of disappearance of A. Next one. What about this one? Let's write it down. It's called rate of formation of B. Rate of formation of B. Rate of formation of B. So any equation if they are giving, so we need to write like this. For example, AA, one equation AA plus BB, right, gives rise to, right, BC plus DD, right? So average rate or instantaneous rate, we can write anything. For example, if I am writing the instantaneous rate directly, right, minus 1 by A dA concentration by dt. So otherwise minus ikkada raskochu, right? 1 by A minus dA concentration by dt is equals to, write it down, 1 by B minus dB concentration by dt is equals to plus 1 by C or plus ఇక్కడ కూడా రాసుకోవచ్చు, plus 1 by C plus dC concentration by dt equals to 1 by D plus what dd concentration by dt. Write it down. 1 by D. So whatever the coefficients are there, we'll write in the multiply kada. ఇది ఈ ప్లస్ అనేది దీనికి డినామినేటర్లో dx by dt అలా నేను రాస్తాను. For example, write this one, N2 plus 3H2 gives rise to 2NH3. Write it down for this one. Rate of reaction. Rate is equals to dx by dt. Dx by equals to minus D into concentration by dt. What is this minus? Indicates that decreasing the concentration of N2 is equals to 1 by 3 minus dH2 concentration by dt is equals to 1 by 2 D H3 concentration by dt. So means if you want, you can write total is in the brackets. They're confusing. So when we are writing the rate of equation, whatever the coefficients are there, right? So first it's coming in down. So based on the experimentally, we need to write like this. Whatever the things are. Now, the next was 2SO2 plus O2 gives rise to 2SO3. So write it down for this. Hello. The first level of question they are asking like here. What rate is equals to dx by dt? First, what? 1 by 2 minus d O2 concentration by dt. Okay, is equals to minus d O2 concentration by dt is equals to 1 by 2 plus d O3 concentration by write one more N2O5 gives rise to 2NO2 of O2. Average or instantaneous, both are same. Okay, but the thing is, I told you, case of differentiate mode lo తీసుకుంటాం instantaneous times to 0, then differentiation form d will take. అది ఉన్నా కానీ మనం డిఫరెన్షియేషన్ అందుకోసమే డిఫరెన్షియేట్ చేస్తాం. ఇంటిగ్రేషన్ డిఫరెన్షియేషన్ తెలుసు కదా. O2 2O plus, come on, write it down. Rate is equals to write it down. dx by dt minus d N2O5 by dt, right, equals to by 2 D NO2 concentration by dt equals to 2 run. Already it is in the right fraction mode. So write up 2 plus DO2 concentration by dt. Same. This is also అందుకోసం ఈక్వల్ రాస్తాను అంటే దట్ అది ఈక్వల్గా అయిపోయింది ఎన్నిసార్లు అవుతుంది అనేది నేను నెక్స్ట్ క్వశ్చన్ ఇస్తాను ఈక్వల్ గెట్ నేను క్వశ్చన్ ఇస్తా అర్థమవుతా ఇస్తా dx by dt rate is equals to plus dH2 sorry minus so minus means what changing the concentration minus d H2O2 concentration by dt right equals to d H2O dt equals to 2 d O2 concentration by now. So why we are doing all these things, right? Write a question. For a reaction A plus 2B gives rise to C. For a reaction A plus 2B gives rise to C. Write that one. C. The rate of formation of C is 0.05. 0.05 mole per second inverse. Mole per second. Calculate the rate of consumption of A and B. Calculate the rate of consumption of A and B. Calculate the rate of consumption of A and B. Calculate the rate of consumption of A and B. So how we need to solve this question? For a rate, what is the units for rate? Concentration by time, right? Hello. Whenever the rate is coming, what is the unit? Sometimes I'll ask. Concentration by time. Concentration means what, Nana? Mole per liter. For example, if you are taking mole per liter by time. Time means second or minute we can take. For example, minute. Or time, I'm just writing the time, okay? Depends on conditions we can take. What is in mole? Depends. Mole per liter, what is in non-bati? Time inverse. Time inverse means what? Seconds aithe second inverse, minute aithe minute inverse, hour aithe hour per inverse. Doesn't matter. Unit nana. Now in this case, how we need to solve? Rate of reaction is equal to minus dA concentration by dt is equals to 1/2 minus dB concentration by dt is equals to this dC concentration by dt, right? So we need to equate. What is the rate of consumption of A? So minus dA concentration by dt is equals to, right, Nana, this dC concentration by dt. So this value already given 0.05. Directly we got the answer. But whereas in this case minus I decreasing the concentration consumption, right? So where minus dB by dt is equals to 2 into this half will comes in this side. 2 into 0.05. How much, Nana? 0.1. So these are the answers. Clear, everyone? So why we are just equating, why we are doing all these things? The minus is that I told you, minus is indicates us what? Decreasing the concentration of reactant. Less is indicates increasing the, so the value and the consume అవుతుందండి. Depends on the equation. That's the reason I clearly telling that. ఇప్పుడు A and B, A 1 mole తగ్గితే B 2 moles తగ్గుతుంది. అర్థమవుతుందా? రైట్? సో మొత్తం ఈక్వల్గా అన్నప్పుడు ఇట్ డిపెండ్స్ ఆన్ ద కోఫిషియంట్. సో ఫర్ ఎగ్జాంపుల్ A 1 mole అయితే B 2 moles కన్జ్యూమ్ అవుతుంది. అప్పుడు ఎట్లా కన్జ్యూమ్ అవుతుంది? 0 పాయింట్ ఇలా. రైట్, వన్ మోర్ క్వశ్చన్. దట్స్ ఓన్లీ నేను అడిగిన క్వశ్చన్కి నేను అందుకోసం చెప్పింది. For a reaction N2 plus 3H2 gives rise to 2NH3. For a reaction N2 plus 3H2 gives rise to 2NH3. For a reaction N2 plus 3H2 gives rise to 2NH3. Rate of formation of ammonia is 2.4 into 10 to the power of minus 3. 2.4 into 10 to the power of minus 3. Right? Molarity in minute inverse, for example. Mole per liter minute inverse. Or molarity also we can use. Calculate rate of consumption of N2 and H2. Calculate rate of consumption of N2 and H2 and rate of reaction. Rate of reaction. Reaction N2 plus 3H2 gives rise to 2NH3. The rate of formation of ammonia is given, right? Rate of formation of ammonia. So come on, the rate of consumption of N2 and H2. టోటల్ నేను ఇచ్చినాను నేను అది. ఇప్పుడు రాసుకోను ఎట్లా నీకు ఎట్లా అనిపిస్తుంది? ఇది రేట్ ఆఫ్ ఫార్మేషన్ ఆఫ్ ఫస్ట్ రైట్ దే dN2 concentration by dt is equals by 3 minus dH2 concentration by dt is equals to by 2 plus dNH3 concentration by dt. So this value actually I gave you. Which value? This particular value, 2 into 10 to the power of minus 3. So minus d N2 concentration by dt is equals to, right, 1 by 2 into total value 2.4 into 10 to the power of minus 3. This is what? For hydrogen, minus dH2 concentration by dt is equals to 3 by 2. So 2.4 into 10 to the power of minus 3. So this actually 1 by 3, right? This 3 comes over here and already 1 by 2 is there. So rate of reaction, how can we say? So what is, I told you rate of reaction means I gave you the two definitions. Decreasing the concentration by reactants are increasing the concentration of products. N2 plus 3H2 gives rise to 2NH3 here. Huh? So which one would be better? Products side, because E ఒకటే ఉంది కదా. So rate of reaction is equals to increasing the concentration of products. What? So 1 by 2 into plus 2.4 into 10 to the power of minus 3. So nothing but 1.2 into 10 to the power of minus 3 is the rate of reaction. Same. అర్థమైందా? So just do as a homework one more question. Homework. For a reaction A plus A gives rise to, for a reaction A gives rise to 4B plus C. For a reaction A gives rise to 4B plus. Okay. The concentration of B increases. The concentration of B increases 4 into 10 to the power of minus 3. 4 into 10 to the power of minus 3 in 4 into 10 to the power of minus 3 molar in 10 seconds. In 10 seconds. Calculate the rate of reaction. 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 Correct. 10 to the power of minus 4 వస్తుంది ఆన్సర్. So, and what is the difference between average rate and instantaneous rate? I told you, right? For example is going right. Change in the concentration time. For example, the time, for example, reactant is concentration is decreasing, right? So time T2 minus, for example, T1, T2, right? T2 minus T1 we can say. But particularly instantaneous rate means what? Within the fraction of seconds. So time T is equals, so that cases instant rate we will take. So there is no much difference. A lot of people are confusing that, right? Next, one of the important term, rate of reaction. Put the heading, rate of reaction. Rate equation or rate law. Next, put the heading, rate equation or rate law. Rate equation or rate law. So it is important. This equation, write one statement. The equation which give the exact relationship between the equation which give the exact relationship between rate of reaction, rate of reaction, rate of reaction, and concentration of rate of reaction and concentration of reactants is called, concentration of reactant is called rate equation or rate law. Rate equation or rate law. For example, Nana, A plus B gives rise to products. So here rate law speaks about only the reactants, right? Rate is directly proportional to here A power, so some x, B power y. Imagine, for example, AA plus BB gives rise to products. Rate equation or rate expression, how I'll write? Rate is equal directly proportional to A power some x and B power some y. So this x may or may not equals to A. May or may not. May equal, may not equal. This x and y are determined by experimentally. But in case of law of mass action, where I explained, in equilibrium I explained. For example, say AA plus BB gives rise to product according to law of mass action. Mass action rate, right? Rate is directly proportional to A power A, B power B. Means whatever the coefficients are there, we will take according to law of mass action. But according to rate equation or rate law, right, we won't take like that. This is x and y, what Nana? Determined by experimentally. This is theoretically, whatever the coefficients are there, directly we'll write according to law of mass action. But here, we'll write this is experimentally determined. So now write it down, x is equals to here, x is equals to order with respect to A, x is order with respect to A, with respect to A, y is order with respect to B. The total order is equals to, the total order is equals to x plus y. The total order is equals to x plus y. Right. So put the heading, write this, right? Order of reaction. Put the heading, order of reaction. Order of reaction. Order of reaction. The sum of powers of concentration terms. The sum of powers of, the sum of powers of concentration terms. In the rate equation, called, the rate equation called overall order or total order of the reaction. Overall order or total order of the reaction. Right? Order is determined by experimentally. Right, one more point. Order is determined by experimentally. Order is determined by experimentally. Order is determined by experimentally. And order of the reaction, order of reaction may be positive integer, may be positive integer, positive integer, or negative, or negative, or fractional, or fractional value, positive, negative, or fractional, or 0. 0, anything is possible, any order is possible, negative order is also present. Next, the order of reaction is independent of, the order of reaction is independent of, the order of reaction is independent of stoichiometric representation of the equation. The order of the reaction is independent of stoichiometric what is stoichiometric representation means? I told you A and B is independent, might be is equal or may not be equal, independent. By seeing the equation we can't say the order. If someone is asking you what is the order of this reaction, means we have to say, no boss, I need to do the experiment, then only I'll tell, because order is determined by experimentally. Means independent of stoichiometry means sometimes we units for is rate constant here. Units for rate constant. Units for rate constant. For example, A gives rise to products number. Rate is directly proportional to A power some n I am writing. Rate is equals to K, right? Proportionality constant, A power n. So this is very important, you know. So K is equals to rate constant, right? This is rate constant. K is equals to what? Rate by A power n. So what is the units for rate? Mole per liter time inverse by concentration, mole per liter, mole per liter for n. Rate, I told you, right? Rate is equals to what? Rate is equals to concentration, change in concentration by time taken. Concentration means what? Mole per liter by time taken. Rate is equals to mole liter inverse time inverse. Rate of reaction. Rate of reaction, and this is what? So if you can calculate, this is K is equals to mole 1 minus n liter minus 1 time inverse. This is 5 star, getting 5 star for this. Very, very important. They keep on asking the question. N number of times they ask this. For example, N is equals to what? Order of the reaction. Write it down. N is equals to what? N is equals to order of the reaction. For example, sir, 0 order. For 0 order, N is equals to 0. For 0 order. Okay, for 0 order, rate constant units they are asking. So what we need to do? A mole 1 minus 0 liter 0 minus 1 time inverse, minute inverse or second inverse, depends. So simply mole liter inverse, mole liter inverse time inverse. But this is 0 order, Nana. For 0 order, K, units for K. And one important note you can observe over here. What is the one important note? This question they are asked a number of times. Rate of reaction units is equals to which of the following rate constant units are same? Rate of reaction units what? Rate of reaction units. Mole, liter inverse, time inverse. Zero order. Zero order rate constant units. Mole, liter inverse, time inverse. Okay, let it be. Just wait. For first order, we'll calculate. First order. First order is equals to what? K is equals to 1 minus 1. Only time inverse. Why time inverse? Huh? Put in mole 1 minus 1 liter 1 minus 1 time inverse, right? Nothing but time inverse. For second order, write it down. K is equals to mole inverse liter time inverse. For third order, mole liter square time inverse. Half order, anything they can ask any type of question. So means for each case the units are different. Each and every time we can't remember. So for the reason, so we need to know what we need to know. N is order of the reaction, right? Because it is determined by experimentally. So zero order or first order or second order, how we are just doing the experiment, then we will determine. Experimentally determined. It's అయిపోతే ఎలా అడుగుతారో చూస్తాను క్వశ్చన్. రైట్ ఏ క్వశ్చన్. వాట్ ఇస్ హాఫ్ ఆర్డర్ రైట్? మోల్ 1 minus of liter of minus 1 time inverse. So means what? Mole of liter minus of time inverse. 3/2 order also we can 3/2. So any order they are asking the rate constants. So this is very very important, compulsory they ask the question. బోర్ అవుతుందా కండి? బోర్ అవుతుందా? 4 hours. Yes. For a reaction, A plus B gives rise to products. For a reaction, A plus B gives rise to products. For a reaction, A plus B gives rise to products, right? The rate of reaction increases 4 times. The rate of reaction increases 4 times For a reaction A plus B gives rise to products. The rate of reaction increases 4 times. The rate of reaction increases 4 times. 4 times. When concentration of A increases 2 times. When concentration of A increases 2 times. When concentration of A increases 2 times. 2 times. Okay? And rate of reaction increases 3 times. And rate of reaction increases 3 times. Rate of reaction increases 3 times. 3 times. When concentration of B increases 3 times. When concentration of B increases 3 times. Increases 3 times. 3 times. 3 times. Calculate individual order. Calculate individual order. Total order. Calculate individual order, total order, and rate equation. Rate equation. And rate equation. Come on, do this. Right or wrong doesn't matter. Anyone didn't write the question, Nana? Shall I repeat once again? Abhikshit Rasava. Sona, vintunnava class no? Sona. Sona. Chakir ga rahiya.